Very good morning to you all. Respected dignitaries, Professor Suresh Sampath from Cranfield University and Professor Yu Cheng Lee from National University Taiwan and Professor Senthil Kumar and Chairman ASI Chennai chapter and Professor Gopal, Dean Academics and Professor I think Vice Chancellor is supposed to come, he is not there, and Professor Ganapati and Dr. Balu from DRDO and Dr. Shanmugam and other dignitaries on the dais and respected faculty members and my dear students, ladies and gentlemen. I think it gives an immense pleasure in meeting the kind of audience. I think Professor Gopal was mentioning the nice audience. I think I could see a bright future of India is in front of me. I think I am very happy to share some of the thoughts of what I have been going through, and maybe 30 years back I was also sitting like you in the front of the dais and looking at what is going to happen and what I am going to do. And today with God's grace and some of the professors and parents have given me the enough courage to come to this level. And first of all, let me thank the Almighty for giving me this chance to talk to all of you. And I think I am happy to note the SRM University is taking up the initiative for the International Conference on Aerospace Systems. See, when we all studied, of course, when we studied, aerospace engineering was available only in few colleges in India. One or few IITs and one or two Indians of Science and one Punjab Engineering College. But otherwise, aeronautical engineering was not known to the people. But today I see almost wherever you go, you will find the kind of aerospace engineering thing. And you are seeing the current development in aerospace engineering. I think Professor Gopal was mentioning a lot of things about Sivathanapillai sir. I think Sivathanapillai sir was with us and he was our first CEO of the BrahMos, which is a joint venture program. He has brought laurel to the country by bringing a joint venture program collaborating with the Russian government. So that is how the aerospace department, the engineering has grown up. And today I was talking to one of the professor, Vignesh, and I was told that the intake of aerospace engineering is 60 into 2. In fact, when we studied, when we all came out from MIT, and aerospace strength was the least compared to any other department. In fact, it used to be 20 and unfortunately our batch it was only 30. So that was the kind of awareness that time. But today I see the college, SRM University is one of the best universities in India. I think Tamil Nadu particular, he has got the aerospace department and having the 120 members intake. That itself gives that what is the kind of future is there for aerospace department. In fact, let me just go into little bit of detail in terms of aerospace, because I have been starting from my studies to today career wise. The entire career was in aerospace area. So I will share few of my thoughts and few of my experiences which may help and which may trigger some of you to take up further as a R&D in aerospace. In fact, today the engineering students, they just join and afterwards, end of the day, they go as a software engineer. I think at least with my kind of experience and the challenges what we faced in aeronautical engineering may trigger at least few of you to continue in aerospace and do contribution to the nation as an aerospace engineer. See, the aerospace engineering, it is basically a kind of integrated engineering. It is not just, we have mechanical engineering, core engineering like mechanical, civil, electrical. But aerospace engineering, it is a specialized one, and where the knowledge of all the basic engineering is required. That is the reason, in fact, aerospace engineering, they have the initial courses like basic engineering things are taught more in case of aeronautical engineer than the mechanical or civil engineers. Basically, any aerospace system, see, compared to any other system which is there in ground, aerospace systems are expected to fly in air. That means you have to have a much more careful design and much more clarity in what kind of inputs you are taking and much more inputs you have to take it from the different disciplines. It is not just suppose if I take aerospace vehicle, for example, it may be a passenger aircraft, it may be a fighter aircraft, or it may be a missile, or it may be a drone, or it may be any other helicopter and whatnot. See, for all these systems, the basic engineering of the aerodynamics, flight structures, propulsion and avionics. See, these are all the specialized things, but as a system you require to have mechanical engineering, civil engineering, instrumentation, electrical, electronics, computer science, whatnot. See, that is how we are saying that it is an integrated engineering. Aerospace is nothing but integrated engineering. Not that aerospace engineer can go to a mechanical domain and work, whereas the mechanical engineer domain can come and work in aerospace engineering. So that is the specialty of aerospace engineering. And I can tell you one thing, tomorrow any aerospace system is being developed. And any system they identify one person as a project director or a program director or the leader, project leader. See, the person who has got the overall knowledge about the entire system, who makes the system very efficient. So that is where the aerospace person has got an edge over any other discipline person to become a project director or to become a project leader for leading the aerospace system design. For example, today you can name any major aerospace systems. Dr. Kota Harinarayana, who has been the forefront for development of LCA. And you can take Madhav Nair sir for launch vehicles, and Dr. APJ Abdul Kalam for missile systems. Of course, Dr. APJ Abdul Kalam started his career as project director SLV3 and then he moved to DRDO. So the idea of this aerospace engineering, maybe people will tell that if you are not getting electronics or computer science or IT, then only people will select whichever leftover subject. It is not so. I can tell you, the aerospace has got a lot of challenges today, and that is the reason I am seeing almost the hall full with aerospace engineers. I am very happy to note this, first of all. So that shows the initiative by the SRM that the international conference can trigger some minds to make the engineering as one of the core disciplines. Just let me get into what are the achievements as far as India or the internationally the aerospace community. See, Indian aerospace industry has come a long way, and today I can tell you any domain in aerospace except for the passenger aircraft. The passenger aircraft, because we are not paying so much of attention because it is available. If you pay money, you will get either from Boeing or from Airbus, you can always get. Whereas the fighter aircraft, today we have got our indigenous fighter aircraft Tejas, which has seen 2-3 Mark 1, Mark 2, and tomorrow we are working on the 5th generation fighter aircraft, that is AMCA. So this is what is being, there is a separate entity created in DRDO ADA, who is responsible for development of fighter aircraft. And you are all aware that when we started this program, people used to comment that this LCA is the kind of latest confusion in aeronautics. This was the kind of loose comments people used to make, but today you can see the people those who made the comment, you can see the flying system of LCA, which is comparable or to, I can tell you proudly that it is much better than some of the fighter aircraft which is there in the world. So that is a kind of a development which Indian mind can do. And as far as missile system is concerned, I think I will go into little more detail because I am basically from missile systems. And in fact, DRDL, which was started in around the 60s as a part of DRDO laboratory, concentrating on developing some of the propulsion systems. And basically we were working on the solid as well as liquid propulsion system. And during 1983, then the Prime Minister Srimati Indira Gandhi felt that India requires, after this some of the tiff between our neighbors, so we wanted to have a missile system. So he has called Dr. APJ Abdul Kalam. He was a project director SLV3, successfully flown the mission. Then she called Dr. APJ Abdul Kalam to come out with a proposal for Indian missile system development. So that is how the IGMDP program has come. And Kalam Sahab was not started with, see, he is a big visionary and thinker. So that is why he didn't go with a single proposal that I want to make one surface-to-surface missile or surface-to-air missile. He went with the 5 missiles so that the entire spectrum of missile we can handle. So he went with the 5 systems, like Agni as a technology demonstrator. I will just touch upon this little later. And Prithvi as a surface-to-surface missile with 50 to 250 kilometer range, and ICAAST as a surface-to-air missile system which will counter the incoming fighter aircraft as well as helicopters. That was designed with a range of around 25 kilometer. And there is another system, SAM system Trishul, which is meant for all the three services. That's why it's called the Trishul for the Army, Navy, Air Force. That has got a range of around 15 km, but that did not see the light of the day because of various other difficulties. But today that same technology is being used to develop some of the systems. One of our project directors is sitting here, and he is being the project director for one of the ICAAST new generation system. And of course the anti-tank missile NAG. So with these 5 systems, the program has been, proposal has been put up to the government, and the government very generously cleared all the 5 systems, and it started in 1983 with DRDO as the focal laboratory. And he has identified 5, in fact we used to call them Panchapandavas, project directors for that, and that is where the kind of thing, for example, the person who has got the electronics background has been made as a project director ICAAST, and the person who has got an aerospace background and also long range systems, Mr. Agarwal as a project director Agni, and General Sundaram was a project director for Prithvi. So why I am trying to bring out this point is, it was the process to select who is the correct person to do this job. So that is how we ventured into the missile system development, and today out of the 5, all 4 systems are with the users. I can proudly say that Agni system technology demonstrator proved the re-entry technology, and with that we have got today Agni 1, Agni 2, Agni 3, Agni 4, Agni 5 as an intercontinental ballistic missile, and the next generation Agni Prime also has been developed and proved, and it is with the user. Whereas in the case of Prithvi, which is being developed using a liquid propulsion. I will go into a little bit of technology. In fact, all the 5 missile systems, we have thought of what are the technologies required to be nurtured, so has been taken into account. For example, Prithvi, we started using the liquid propulsion system, and generally liquid propulsion is used for launch vehicles, because launch vehicle is once in a while you launch and you can have a preparation time, whereas weapon you cannot wait for somebody, and so you have to launch it whenever it is required. So we used to go for a solid propulsion system. So Agni system was energized with a solid propulsion system, and Trishul, ICAAST and NAG, all these things are solid propulsion system. Whereas ICAAST, again we thought, why not we go with the conventional, solid propulsion, why not go with the ramjet propulsion. I just want to give you a little bit about ramjet propulsion. See, any propulsion system, it is basically the chemical combustion take place and the thrust is being generated. So to generate chemical combustion, you require both fuel as well as oxidizer. So in case of solid propulsion, we take both fuel as well as oxidizer to carry, and it is a self-sufficient system. And whereas in the case of ramjet system, we carry only the fuel, whereas oxidizer is taken from the atmosphere. So the limitation of the ramjet propulsion system is it can fly only in the atmosphere. Indian standard atmosphere says up to 80 km we have the atmosphere, but beyond 30-40 it is not the appreciable atmosphere, even though there are some little bit of pressure is available. But this is how we envisaged, and ICAAST has become today the one of the workhorses for surface to air mode, and you can say it is a success story of DRDO and in India. In fact, we were all along importing the missile systems from either Russia or US or Israel and whatnot. And today we have all our missile systems. That is what I can tell you. Today we are self-reliant in missile systems. So I can tell you, all my friends are here. Dr. Balu, Shanmugam, Tyagarajan. We were all part of the missile configuration design. They are all aerodynamics experts, and I just moved from aerodynamics to systems. So that is how I got into the kind of a role in playing a project director to understand all the subsystems like propulsion, avionics, structures, materials and whatnot. So this is all about missile systems, and also it is not the ending story as far as missile system is concerned. Today we have ventured into the joint venture, that is what the BrahMos, which is one of the, it is not the one of the, it is the only supersonic cruise missile in the world, and along with the Russian counterpart we have developed the system, and today we are in the position to export the system. In fact, today also we are one of the biggest importer of arms. But we also started exporting things. That is what we started with BrahMos, and I think there are a lot of queries for some of our weapons like ICAAST, QRSAM and whatnot. I think that shows that the aerospace community can add value to the economics to the country also. It is not just only IT people can add economy, and aerospace also can do that. And let me touch upon the launch vehicle. I think Professor Gopal was telling that going to moon, what is the purpose and whatnot. And we started with SLV3 and starting with a payload with a few kgs of payload, and today we are working with tons of payload. Today our GSLV Mark III can carry 4 tons of satellite, which can be put it in that geosynchronous orbit. So that is the kind of strength we have, and also of course you all aware that we have reached moon and Mars mission, everything. And I think sir was mentioning what is so great in going to moon. In fact, lot of minerals and so many other things are available in those planets, and everybody is trying to address it. And that is we cannot afford to miss that bus. So that is why India is also venturing into all that. In fact, government is questioning what is that we are going to get out of it. And still, one is scientific exploration, another one is future, what we can get out of this kind of a situation. So today what we are working is, even ISRO is working on the reusable launch vehicle. In the sense, today what we are happening to send a satellite, you spend all 3-4 stages of rocket motor and it gets waste. And I think you are all aware, recently the American space private space agency SpaceX has proved that the booster, which is a massive booster which takes the payloads of tons of payload, can be retrieved back and can be used it again. See, the kind of a booster what we are talking is today, it is of the order of hundreds of tons. So hundreds of tons, the material cost and the fabrication cost. If I can get back that thing and use it, nothing like it. That is what has been proved by SpaceX. And this is again one of the revolution has taken place in aerospace as a community in the world. And this is going to transform the entire thing. As Professor Gopal mentioned, this conference theme is a transformation. So this is one of the transformation, I can tell you. See, all these years we used to develop rocket motors, use it as a single shot device and use it and forget it. And this transformation is making a lot of changes that you are not going to spend time in making different boosters. So that is the advantage. And also the kind of mission what we are planning. There is a possibility that we can go with a single stage to orbit, 2 stage to orbit, and today we are working on both the things. And also as far as launch vehicles are concerned, as a DRDO, we are also working on some of the launch vehicles to support only the defense satellites. See, defense also requires, see, whatever ISRO is doing, it is commercial satellites, and whereas we require for defense purpose some satellites. That is what DRDO also involved. So this is the kind of a story how our scientific growth has happened in terms of launch vehicles. And coming to the fighter aircraft. Fighter aircraft, of course, we were all along working with the imported system, either it is call it MiG or Mirage or Su-30 or to the latest Rafale, and we also ventured some few years back the Tejas aircraft, that is a light compact aircraft. The LCA was envisaged as an unstable vehicle. I think you are all aero community, you should understand what is stable and unstable thing. Any system, see why aerospace system is so critical. Say the car which is flying in road, when there is a disturbance, it can manage and it can stop, or it can with a little bit of scratch it can get away. Whereas the aerospace vehicle, if it gets a disturbance in the air, what will happen? If your controllability is not so good, so you are likely to get failure. So that is why the aerospace department or aerospace vehicle design is so critical in terms of quality and reliability. So what I wanted to tell you, the stability. The stability in the sense, when a system is flying or in a state, if there is a external disturbance, if it can come back to its original state, that is called a stable vehicle. That means you are just moving, somebody is giving a kick, you can come back, that means you are a stable person. Suppose the moment somebody gives a kick, you are falling down, that means it's unstable one. That means you don't have controllability or capability to bring back your situation. But if you want to do a lot of maneuver, you require to have a vehicle with highly unstable vehicle. So that is where we started with a highly unstable LCA, and it is able to do the job, and we can compare. That's what I was mentioning. We can compare with any other system which is there in the world. So this is where our story about fighter aircraft. In fact, during the Shakti, our development program on LCA was going on, and we require some support from the, of course, US. And immediately after that Shakti, all our teams have been taken back. In the sense, they have been sent back. So because India is working on the nuclear program, so we will not support them for fighter aircraft technology. So that has given us kind of a opportunity that yes, now nobody is there to give us support. Let us work on ourselves. So that is how we have come today. The LCA Mark 1, Mark 2, LCA naval version, and today AMCA. So what I want to tell you is the opportunity makes person very robust, and I say always the necessity is the mother of invention. So always when there is a necessity, when there is no opportunity, obviously you will flourish well. So this is all about our aerospace vehicle development in India. As far as the passenger aircraft is concerned, it is not that we have not attempted. In fact, NAL is working on the I think 12-seater or something Saras aircraft, and NAL has a CSIR laboratory which is doing the fundamental research on aeronautical engineering, and which houses the huge wind tunnel which is being used by DRDO, ISRO, and everybody to evaluate their vehicle characteristics in aeronautics. So in passenger aircraft also we are doing a lot of work, and which requires little more effort, and that is what is being done. Maybe I have no doubt with this kind of aerospace engineers coming up, maybe in years to go, maybe 5 years or so, I think we will have our own transport aircraft. This is what my wish, and hopefully this will happen. Let me touch upon the aerospace industry where we are heading to today. See, today, as you are all aware, I think maybe you would have studied, we are starting with the aerospace starts with the subsonic, transition to supersonic is transonic, then supersonic, then finally we are going to hypersonic. See, today we have the systems which are flying in sustained mode in supersonic speed and subsonic speed. Of course, we are moving from subsonic to supersonic to transonic zone, whereas the hypersonic, so the entire world is working on the hypersonic systems. The hypersonic systems, basically today even ballistic missile which touches the hypersonic speed but never work in a sustained hypersonic speed. Hypersonic speed, when I say it is beyond Mach 5, that is speed of sound is 345 times of speed of sound. So in the hypersonic domain, I think the entire world is working. US, China, Japan, Australia, Israel, everybody is working, and we are also joining them, and as a hypersonic technology. And hypersonic technology, I will just bring out a little bit. I was talking about the scramjet engine. The scramjet engine is basically the vehicle or the missile flies in supersonic speed. The combustion, what I was mentioning to produce a thrust, the combustion takes place in subsonic speed. Whereas in the case of hypersonic systems, the missile is flying in hypersonic speed, but the combustion takes place in supersonic speed. The criticality lies with the holding the flame in the supersonic speed. So that is where we have taken up a project, hypersonic technology demonstrator program, and US is working on X-43, X-53, and high-shot program, and there are nations who coming together as a joint nation program. They are working, and till now I think the technology level is up to 20 seconds of flight has been proven, and we have also attempted 2 years back. We had successful flight of 10 to 15 seconds, and today we are working on two systems. One is the powered, another one is unpowered hypersonic. I'll just touch upon what is powered and unpowered. Basically, the ballistic missile, what it does, it takes the kinetic, it accumulates the kinetic energy using the solid rocket motor propulsion and flies with that kinetic energy. So the hypersonic glide is nothing but the same booster will give the velocity and design an aerodynamic vehicle, and it will fly in the hypersonic speed in a sustained manner. That is what you call is the unpowered hypersonic. Whereas the hypersonic powered one, so you design a scramjet engine where it will fly in Mach 6 and above, and the combustion takes place at Mach 2 or so, and then we will get a sustained hypersonic speed of 6, Mark 6 and above, and with the whatever kind of fuel we are using, it kind of fuel you can carry, and you can have the endurance to the tune of few hundred seconds to few minutes. So that will ensure the time critical targets as far as the military is concerned. As far as civil is concerned, the hypersonic technology, once it comes, today from here Delhi to London, we are flying few tens of hours, but tomorrow if the hypersonic system comes, you can fly in few hours. So that is the idea of hypersonic technology. I think I have no doubt with this future generation, the hypersonic technology will be in reality, and hopefully we all will fly in hypersonic speed. The another one is the aerospace technology development in compared to US or China, compared to these two countries. In India, the private partners are not willing to come to aerospace area. Why? Because all along the aerospace related work is handled by the government departments. In fact, I was surprised, all the aeronautical conferences handled by either DRDO, ISRO or Aeronautical Society of India. And whereas I am very happy, I am thankful to the SRM University management to take up this initiative to conduct a conference on aerospace technologies. See, why I am bringing this point is, whereas in US, you have a company like Raytheon, GE, like there's so many companies are SpaceX, like those so many companies are there investing a lot of money in aerospace systems. Whereas in India today only slowly people are coming. That is because of the government support that we have to encourage the private partners also. As far as the DRDO is concerned, we are expected to do only the R&D, and the production and some kind of establishing system has to be done by the private partners. So that is the initiative by the government. I think we are working towards that. I think let me touch upon what are the future trends of aerospace systems or aerospace engineering. To start with the autonomous flight systems. See, today we are working with UAVs, which is because fighter aircraft is a dangerous situation, because if you are flying with two pilots, so the two pilots are in danger if you are flying in enemy territory and trying to put a bomb. So if the same pilot aircraft, if we can make it as a pilotless aircraft, so you don't have to worry, you can send that fellow deep inside the enemy territory and put the bomb. So that is the current trend in working on the autonomous flight vehicles. In fact, UAVs are doing the job, and tomorrow we have to have a sophisticated fighter aircraft which is pilotless. And to enable all these aerospace systems, whether it is autonomous flight or whether it is hypersonic flight, the additive manufacturing. This is another thing. I think this is where the mechanical engineering support is very much required for aerospace engineers. The aerospace engineer always very sensitive about the weight. See, because the ground system like any truck or car or anything, it can have any mass and not a problem. Whereas the aerospace, the moment you increase the mass by 1 kg, if you see the launch vehicle, we call it 1 kg satellite is something like so many dollars required to launch. Same way, aerospace vehicle, the mass is going to play a major role. So the additive manufacturing, which is a very effective way of making very light material, and also wherever required you can give thickness. See, that is where the very important of this advent of these composite materials. How we have experienced the weight gain as well as strength gain, we got it through composite material. It is just because the strength is so much and not with the equivalent weight. So the additive manufacturing is going to give us a lot of input that you can make a very small system which will have the high strength kind of a thing. So the other one, the supersonic flight. I was mentioning that hypersonic flight, when it comes, we can do it. In fact, in 1947, US has come out with a Canard system, Concorde, which is supersonic passenger aircraft. But due to some reason, that could not be pursued. Maybe with the current advent of lot of computational power and whatnot, and maybe in future we will be getting into supersonic flights, if not hypersonic speeds. And AI, I think it is a buzzword today. I think nobody can escape from AI. I think today you open your mobile and it starts with AI only. So I think you all aware that how AI works. and I can take one or two examples. You take any site in internet, you start searching some product, and within no time you will get 100 advertisements on the same product. It is just because of the background, the AI is working, and somebody is trying for a mobile, or somebody is trying for some specific equipment, so immediately it pops up. These are all the materials available in different places. So that is where the AI is working. And if you see today, I think you people would have experienced this experience. Of course, I also experienced the aircraft, whatever the booking when you do, you search for a flight from Delhi to Chennai. So first time search, your charge maybe around 7,000 or 8,000. You do the same search 2-3 times to see the flexibility of timing and other thing. You will find the charge goes from 7,000 to 20,000. It is nothing. It is just take the input, how many people are searching Delhi to Chennai. That means the demand is going up. Now let us make the charges more and more. So that is where the AI works. So the AI is now no technology or no discipline can escape from AI, and I think we all need to work, and particularly aerospace engineering. If we can inbuilt AI, today whatever we are saying, quadruple redundancy for fighter aircraft or passenger aircraft. See, if the AI is there, you can get to know what is the kind of problem I am going to face maybe another few seconds or another few minutes. If I can judge that, I can certainly bring out a solution. What is the problem I am going to get, how I can overcome it. So the artificial intelligence, the big data, machine learning, these are all going to be the future. And it is not that, see, you have to be a domain expert in AI or domain expert in all these things. There are people working on it, and only you have to be smart enough to use the technology what is going to be developed. That is the future of aerospace. The AI is going to play a vital role. Then the materials. This is another very important thing. When I was talking about hypersonic, and we are going to experience the temperature to the tune of 2000 degrees centigrade. So 2000 degrees centigrade is not just, and we are planning to fly sustained. That means it has to survive for a few seconds or few minutes. So the kind of material what we are today, we have some technology. In fact, our material experts are working on it, and we have the materials which can sustain for few seconds or few, maybe to at the maximum 1 or 2 seconds or 1 or 2 minutes. But we are looking for materials which can withstand that kind of a thing. And it is not just withstanding temperature, and also today's world, the defense. When I am designing a fighter aircraft, I have to be worried about the SAM system which other fellow is having. So that means essentially I have to reduce the RCS, the radar cross section. So if I can reduce that by making different material. Recently I heard IIT Kanpur has come out with a coating material which can absorb the radio frequency. So what I am trying to tell is, this is another domain which again we all need to work. Then only we will be in the game of aerospace engineering. Of course, the propulsion, and we were all working. I think I will little bit I will go into. We are working with a solid propulsion, which gives the performance index of around 300 seconds as a specific impulse, whereas liquid gives maybe a few hundred seconds of specific impulse. But we need to work on systems which will be much more efficient, and also which will be much more eco-friendly. In the sense, we are working on the green propellants also. Today, in fact, the entire world is working on the kind of noise pollution the aircraft when it is taking off or when it is landing gives. So the entire aeronautics community is working on that engine, how we can make a noiseless engine which will make the environment eco-friendly. And the other one more point, when I touch upon engine, I just want to bring out the challenge ahead of us is the gas turbine engine, which today, even though we claim that LCA is matured and it is working, and still we are working with the GE engine which is imported. And I urge the aeronautical community, you all should think that how we can overcome the gas turbine engine technology. I think the entire country is working on that. Some of the specialized teams are working, and maybe in a couple of years, my feeling is the smaller engines we have matured the technology, whereas the bigger engine we are still lagging behind. We need to work. I feel the kind of future generation are going to come. You all will overcome, and will give the indigenous system for fighter aircraft. To conclude, this whatever the trend I was talking about, with all this, if you can make the serious change in this aerospace community, we will be in the industry, and otherwise we will be like the today where we are almost 10 to 15 years behind some of the developed nations, and we are now thinking of bringing a Vikshit Bharat, which is to Prime Minister's vision that 2047 we should be a kind of a powerful nation, the developed nation. So I have no doubt with this kind of enthusiasm among the young budding engineers, and we can make the Vikshit Bharat. And ladies and gentlemen, the entire world is waiting for you. I think we all have to work with a vigor. And once again, I'd like to thank the management of SRM to come out with an international conference on aerospace, advanced aerospace technologies. And I am happy to see some of the professors from Cranfield as well as Taiwan and our own DRDO scientists. And it gives the kind of initiative that you are in the business and you are going to make it happen. Ladies and gentlemen, once again, thank you for the kind opportunity to share some of my experiences and what we are expecting as a country. And I have no doubt that India in 2047 will be a developed nation. Thank you. Jai.